Well, as promised, I'll try to start with a little bit of history about myself. I'm a mathematician by profession, and optimization is my passion. I've always tried to make the most out of the resources that are available. I've worked in IT for logistics for over 15 years. The first 10 years were somehow um, mostly research. I worked in a vehicle tracking company, and we gathered a lot of data about the paths of vehicles. And we try to somehow make the most out of it. So we try to see how these data can be utilized in the best possible way. So eventually, our biggest project was that we developed an algorithm which could calculate the road network out of the vehicle tracking data. So we calculated both the geometry and the topology, so the connectivity of the road network. And that was really quite an achievement. Also, I remember we showed this to the head of research of one of the two major uh, two major mapping companies in the world. And that guy said that he was sure that was not possible. Well, we showed them that it is possible. So later on, I was also working on the speed profiling of road network, time-dependent routing, and eventually also route optimization, uh, development of a tool. Later on, the company was acquired by another one from North America, and then I moved to business development of route optimization software. So I was in charge for the area of the Balkan, and I remember I did a lot of different studies and simulations of various largest companies in the region, and always, except in one case, we showed that the savings are between 10 and 30%. So this still holds. This is really the rule of the thumb shows that if you are doing if you're using fixed routes or doing some let's say manual route construction, using this classic route optimization can surely save between 10 and 30% of the costs. So yeah, here's also a nice scheme that shows what the problem is really all about. So you have a lot of locations that you need to visit, and several vehicles or some resources, and then a lot of constraints like time windows, capacities of the vehicles, working time, and so on. And all of this has to be taken into account, and the routes need to be constructed in the most efficient way. Um, of course, you need to decide for each location. You need to decide who will visit this location, or which vehicle, which resource, and also what's the sequence going to be. So is this one going to be the first, or this one, and so on. So this is the classic vehicle routing problem. Classic optimization solves this. And as mentioned, the usual savings that can be achieved here are between 10 and 30%. And this is usually in all parameters. So number of vehicles, kilometers, time, um, cost, and so on. And but everybody else, everybody here assumes that there's only one connection between each pair of locations, which is usually the fastest route. In this way, you can really pack the most locations on a single route. However, this is a good strategy, but not always the best. For example, here you see that the fastest route is quite long. Therefore, the distance is increases compared to, let's say, the fastest route, the shortest route. However, on the other hand, the shortest route might take too much time, which may be in contrast with the constraints that you have. But there are many, let's say, trade-off or alternative solutions which are somewhere in between, shorter than the fastest and faster than the shortest. So I really remember vividly, I was at one of the sales training at my former company where I was employed, and we were checking comparisons between the plan and the execution. And the plan was usually better than the execution, because of course the route optimization is so great, and well, it actually really is. This is one of the most complex mathematical problems. However, in one case, I remember that execution was better than the plan. The distance was about 10% shorter, while the time was a bit, maybe a few percents longer. However, I was really shocked by that, and I asked my boss, so how is that possible that somebody drove better than what our super duper program computed? And the guy said, well, you know, he took a shortcut where he drove where he wasn't supposed to. And I was really baffled with that. And in the next years, I really tried to somehow model what is going on with a mathematical model. So we know that people, humans, are intelligent, and they know how to find good alternative solutions, alternative routes, shortcuts. But computers were somehow not capable of doing that. You could just select a single criterion and optimize according to that. So either the shortest route or the fastest route, and that's it. And also Google Maps was not providing these kind of trade-off solutions to me. So I was working on my PhD in mathematics and eventually managed to develop this algorithm which could provide this solution. So here's an example. If this dot represents the fastest route, and this one the shortest route, these dots in between represent these shortcuts or trade-off or alternative solutions. So the ones which are shorter than the fastest and faster than the shortest. So if you plug this into the classical route optimization problem or solver, so instead of having only one option between each pair of locations, we can provide a lot of them. So this adds a new dimension to the problem, makes it more complex. However, on the other hand, it also enables finding better solutions. We've seen that we can boost the performance of the classic optimizers by up to 40% if we use this. So how is that possible? For example, if we have a time window until when we need to arrive to the next location, for example, we need to arrive by this time. So what's the best option to use? This one, the shortest route, which is still within this time window. So this is the distance that we're able to save. So typically on already optimized routes, our add-on can save additional 5 to 15% of the distance. That's with the cases that we've checked so far. But that's, of course, mostly for some local distribution scenarios. Also, yeah, I mentioned I was working in sales for a while, business development, and the problem was that business model was license-based. So there was a large investment at the very beginning, and then the savings somehow accumulated over time. So now when I have my own company, now for several years, OmniOpti, all the best in Latin, we change this business model into software as a service or subscription-based model. So you just pay a monthly subscription like you do for your mobile phone or internet and similar services. And this subscription, this fee represents just a portion of what you actually save. So return on investment is positive practically from the very day one. And actually, for the larger companies, we provide the modules which can be integrated into existing solutions through our API. So the user interfaces and all similar stuff can be left untouched, can remain the same, because all the workers are used to that and so on. They don't need to get used to another user interface or something similar. However, just the engine that's under the hood, somewhere hidden, this is changed or somehow improved. So just an add-on which boosts the performance of the existing solutions. Also, how are we different than the others? We can take several objectives into account. We are talking now about time, distance, but it can be also costs, emissions, safety, or anything else that you can actually describe with a number in each connection. So for example, regarding Google, they would give you the fastest route and maybe one or two alternatives usually, but these alternatives are not always Pareto optimal, meaning they can also be here or here. They can even be longer than the original solution, less efficient in a way. But all the solutions that we provide are also Pareto optimal, which means non-dominated, which means there's no better possible solution. These are theoretically the best possible solutions. Okay, and also, yeah, so we can take more objectives into account and also provide more alternative solutions that you can choose from. And what we're looking for are actually partnerships and projects where we can prove and deliver our added value. We have already established several partnerships with, let's say, some system integrators or some providers of solutions which are complementary to ours. But of course, there's still a lot of room for expansion globally. So also if you are or know somebody who is active in this space, maybe some consultants, system integrators or something like that, we are still expanding our partnership portfolio, let's say. Okay, so as mentioned, we're adding a new dimension of route optimization, and hopefully this might be also done with your help, or maybe on your case, if you do some logistics operation yourself, then we would be really happy to discuss your business and see if our solutions can be beneficial for you. I learned that it's difficult to say in advance if something is working in a specific case or not, but we just need to check and do a test. For example, we did a project with a large container port, and I was afraid that we are not able to achieve a lot of savings in that case. However, we show that we can deliver $20 million of savings each year. So that's quite a lot of money, and I hope that everybody is satisfied with the results. So yes, as mentioned, this is our core solution, multi-objective route optimization. However, now we are also going into some other domains and some other, or let's say, some other sub solutions like warehouse arrival management, so booking of time slots, and yard management, meaning providing various, let's say, functionalities about the documentation, about the assigning to delivery doors, delivery ramps, and so on. So we are expanding also the portfolio of our solutions. Also, if you have any questions, just maybe type in the chat, and I'll be happy to answer any questions. Also, what I wanted to say is that we have already established several partnerships, also with our technology partners, which are providing some solutions complementary to ours. And in the following events that we're planning to have in, let's say, approximately every 2 weeks, we also plan to discuss what our partners can offer, and perhaps also why is the combination of our solution with theirs so powerful. So very often you can say that the joint solution is more than just a sum of its parts. And I believe that holds in many cases that we are working on right now, and we'll try to explain more about it in the next events. So stay tuned, and we'll notify you about that. Also, we would love to add you to our newsletter or mailing list in order to be able to send you more information about such future events. Of course, this one is the initial one, our first try at this, but I'm sure there'll be many more, and I'm sure it will be improving, and the topics will be more and more interesting. Maybe let me just also show you a little bit about how this classic optimization also works. I think it might be interesting for a lot of people. So let's say here's a small example of some delivery routes which need to be delivery locations in our area. And generally, usually you would have some fixed areas or routes, or sometimes the dispatchers would modify this manually and change the sequence and who is going to deliver a certain location. So is this one going to be on this route or on this route, and so on. But if you have the right tool, then you just press a button and it starts. So it takes a few seconds for the initial, okay, now we already have solutions, and initial costs, which then slowly decreases. The longer it takes, so this classic route optimization is, as mentioned, a very complex problem. So what you do is an iterative process. You try to modify it this way and that way, and so you're trying to improve it somehow. And in the beginning, this is a bit simpler, so the savings grow, or the cost decreased more rapidly, but then it slows down slowly, and But generally, as mentioned, the usual result is, let's say, 10 to 30% of the savings compared to manual routes. Okay, so when you don't have any time left, you just stop the optimization and the result will be shown right away. So here's an example of a route which is quite efficient. So you don't need to, and all the constraints are taken into account, like one-way streets and so on. And you can see also the Gantt charts to know what's happening. So the green are loading or unloading, the blue dots are driving times, and the red is waiting also, and so on. So all the details are well taken care of. Okay, so this is a little bit about the classic optimization also. But yeah, I think we'll also go into more details about such about specific topics also in the next events, like maybe probably once we'll focus on the classic optimization, one on this multi-objective, and once also on this warehouse arrival management. Unless if you have any questions at the moment, then I'll be happy to answer them. Otherwise, we can go maybe in more details some other time. Okay, no specific questions so far, as I can see. Well, you can type it in chat or maybe even unmute yourself and maybe ask the questions. And if not, then I'll thank you for your attention right now, and invite you to the next events that we plan in the near future. And just make sure that you whitelist us our email address so that our messages will reach you, so that we can deliver more value to you and your partners. Okay, so this is it for the moment. Thank you very much for your attention, your time, and I'm wishing you all the best. OmniOpti also in the future. Thank you very much and take care. Bye.